Alright, so now I'm going to pick random question from your multiple choice packet. And I don't actually have what page they're from. So just pause if you want to look for the question so you can actually do the question together with me. So first question says, how many critical points does the function have? I chose this one because it had a nice product and chain in there. Critical point is when f prime is equal to 0 or f prime is equal to undefined. So the key is find f prime. So we're going to take f prime of x is equal to, leave the first term, actually, let's back up a little bit. Let's take the time to find the derivative of the pieces. So here, the derivative of this piece would be bring the power down, leave the inside the same, multiply by the derivative of the inside. This guy's derivative would have been bring the power down, leave the inside the same, derivative of the inside. So there are the derivative pieces that I'm going to use. So now I'm going to leave the first term alone, multiply by the derivative of the second. I'm going to write this out, and I'm going to not write the times 1, plus leave the second term alone, multiply by the derivative of the first term. Now here you might get tempted into thinking, oh, I need to multiply everything out, but if you remember, I always say try to see if you have a common factor. There are 2 common factors. You're going to notice that x plus 2 to the 4th is common, and then x minus 3 to the 3rd are common, so I'm going to actually pull those out front. And what I mean by pulling them out front, you're literally going to factor those 2 terms out. When I do that, my leftovers would be whatever's not in that box. So let me see. I factored out the x minus 3 to the 3rd power. I'm also supposed to factor out 4 of these, so this will drop to a power of 1. So I have left from the first term x plus 2 times 4. Now plus the second term, I am going to take out and factor out, I think, 3 of these, so this will drop down to a power of 1. We get x minus 3 times 5. So what do we have here? We have x minus 3 to the 3rd times x plus 2 to the 4th times 4x plus 8 plus 5x minus 15. And then this part here becomes 9x minus 7. So we get x plus 2 to the 4th, and we get x minus 3 to the 3rd. We want to set this equal to 0, and we get how many? We get x equal to 3, which is one of them, negative 2, which is another, 7/9, which is the last one. And then you have to realize that f prime never equals undefined, so we only get 3 of them. Letter C. Second question, what's the minimum value of f of x equals x ln of x? So I'm going to try to take the minimum of the function x ln of x. So f prime would be the first step. Take the derivative of whoever you want to find the minimum of. So I'm going to leave the first one, derivative of the second, plus leave the second one, derivative of the first. We end up with 1 plus ln of x. Now, if I want to find the minimum, I'm going to set that equal to 0 first, and I get ln of x is equal to negative 1. ln of x can, will equal negative 1. I'm going to take e to both sides. We get x is equal to e to the negative 1. That's the same thing as 1 over e. Off to the left, I'm actually going to find if f prime of x equals undefined, and because there's no fraction here, we're not going to worry about the undefined. I know from the very beginning that the domain was greater than 0 because ln can only use positive values, not even 0. You can't take the ln of 0. So now that I have that, I'm going to do my sign chart for f prime. Here's 0, which is here, let's see, 1 over e, or e to the negative 1. The derivative is 0. In this case, we want to substitute in something smaller. where are we? 1 plus ln of x. So, if you remember, let's see, the ln of e to the negative 1 is negative 1. So this here would give me the ln value to be negative 1. If I pick a smaller value, it should be less than negative 1, which would cause this to be negative. I'm going to pick 1,000. 1 plus ln of 1,000 would be positive. If anyone has trouble, this is where you would have the most trouble. It's really understanding the behavior of ln graphs. So we end up with the minimum happening at 1 over e, but the question was not what is the x value, it wants to know the y value. So the y value we would find by substituting back into the original function equals x ln of 1 over e. But I'm actually going to rewrite that so that we have x ln of e to the negative 1. And the reason I want to do that is, number one, I forgot to put in 1 over e for the x value, so I'll put that in. And then the ln of e, I'm going to bring down the negative 1. And then the ln of e simplifies to positive 1. So the value is negative 1 over e. Notice I did this little move, take the power into the front. So this negative 1 is now this negative 1. And ln of e, this ln of e that was still there, is now 1. So there's our minimum value. Minimum value means y. You want the y value. The derivative of f, I'm going to rewrite that so it looks a little more normal here. The derivative of f is given. And how many points will the graph have a relative maximum? So this question takes no time at all because we get to set this equal to 0, and we get x equal to 0, x equal to 2, x equal to negative 3. We don't even have to find the derivative. We are going to put the zeros up. This term right here is always positive, so I'm going to ignore it while doing my sign chart, and I'm only going to do my sign chart using these two terms. So if I substitute in a very negative number, I would get a negative times a negative, which is positive. If I put in negative 2, I would get negative times a positive, which is negative. If I put in 1, I get negative times a positive, which is negative, and then 1,000 would be positive. The other way you could have done that, you can tell by looking at this piece that that's a parabola facing up, and the zeros were negative 3 and positive 2. The parabola would have to look like this. And notice you have positive, then negative, and then positive. So, where do you have a relative maximum? Maximums occur when your sign changes from plus to minus, and the derivative is equal to 0 or undefined. So we end up having only one maximum. What are the values of the function defined? Increasing. So increasing, we want to take the derivative, which would be leave the first term times the derivative of the second, and obviously please don't forget the derivative of the negative x, plus e to the negative x times the derivative of the first. Factor out the common factor, which is e to the negative x. We get x squared minus 3, oopsie, times negative 1, and then plus 2x in the back. How did I do that? If I take this term, notice what's left over. X squared minus 3 times negative 1. If I take this term here from here, we have the 2x left over. That's how you figure out what's on the inside of your GCF. So what do we get? We get negative x squared, positive 3 plus 2x. I'm going to rewrite that as negative x squared plus 2x plus 3. And then we're asked to find where the function increases. So I'm going to set that equal to 0. E to the negative x equals 0. Can't happen. I'm going to factor this and set it equal to 0. So easiest way to factor it is to factor out the negative. And then you get x squared minus 2x minus 3 equals 0. You get x minus 3 times x plus 1. And so we get x equals 3 and x equals negative 1. Now that we have those values, I want to know where f is increasing. F increases when f prime is positive. Let's see. So I'm going to put in negative 1. I'm going to put in 3, 0, 0, e to the x. So the most factored form would look like e to the negative x times negative times x minus 3, x plus 1. Really, I should move this negative to the front, but it's going to stay there for a reason. The reason I'm leaving it there, because I know e to the anything is going to be positive always. So I'm only going to use what's highlighted to the right for my sign chart. So when I put in 0, which is in the middle, 0 would be negative, negative, positive. If I put in 100, I get negative, 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 positive, positive. So that's negative. If I put in negative 1,000, I get negative, negative, and negative. So that's negative. So the function increases right here, where f prime is positive. So negative 1 to 3, not including. How many points of inflection does the graph have? Well, we have the graph of the derivative. Points of inflection mean I need the double prime. To get from here to here, we take a slope. Therefore, we're going to look at slopes. So my slopes are 0 at 1, 2, 3, 4, 5, and 7. My slopes are changing. Let's see. They're increasing. The graph is increasing, so the slope is positive. The graph is decreasing, so the slope is negative. Positive, negative, positive, negative, positive. Therefore, the points of inflection would happen whenever it's 0 and the sign changes, and it being f double prime. So we have 1, 2, 3, 4, 5, 6 changes. Let's see. All right, f double prime is there. When does the graph of f have a point of inflection? A point of inflection happens when f double prime equals 0 or undefined and f double prime changes sign. And this problem's really nice and easy, saves some time, because the double derivative is equal to x times x plus 1 times x minus 2. They gave us this squared. What you should remember is that when you do a sign chart, since this term is always positive, it causes your sign chart to not change sign at the 0, and the 0 would have been x equal to 2. So the only zeros that you'll have a sign change are x equal to 0 and x equal to negative 1. So I'm actually going to show you the sign chart, which you don't need to do, but I want you to see it in case you don't understand exactly what's happening with the sign chart. F double prime can never equal undefined. So given my 3 terms, I am not going to use the x minus 2 term to do my sign chart. So negative would be, negative 1,000 would be negative and negative, so make that positive. Negative 0.5 would be negative and a positive, make that negative. Actually, we'll do 1. 1 would be positive plus times a positive, and then 1,000 would be positive times a positive, so that's a positive. So notice what happens. At 2, the sign never changed. What I don't say is that the signs stay positive. This term is always positive, and I get that can be confusing. The term is always positive, meaning it won't ever change sign. That's what this positive does. So that's what causes the left side and the right side of the 0 to have the same exact sign. So the answer to this was negative 1 and 0 only. Let f be a function that's differentiable on the open interval. Now that we know it's differentiable on the open interval, we know that, well, I guess we know that it's continuous on the open interval. We don't know if it's closed on the endpoint. So if f of 2 is negative 5, so f of 2 is negative 5, f of 5 is 5, and f of 9 is -5. All right. Which of the following must be true? F has at least 2 zeros. F has to have 2 zeros because from point A to point B, that would be IVT, and the 0 in between has to be guaranteed. But then I could do IVT one more time from the top point to the right point, and therefore another 0 has to be guaranteed. So IVT says this one's true. F has at least one horizontal tangent. F has to have at least one horizontal tangent because if they're giving us from 2 until 9 are closed endpoints, but we know that in between 1, use a different color, in between 1 and 10, we were differentiable and that means continuous happens. We're guaranteed that MVT can happen on 2 until 9 because now these endpoints are closed because they gave us those points. The slope between those 2 points are 0. So MVT says that f prime of c has to equal 0 sometime in between 2 to 9. Third part, f of c equals 3. So if you look at what it's asking you to guarantee a y value in between x value of 2 and 5. That would be only from point A until point B. Now this is at a y value of 5, this is at a y value of -5. Every y value from here to here is guaranteed. 3 is in between there, so now I know IVT guarantees this. So now we actually have that all 3 are guaranteed. And that was my last one. Hopefully that was helpful.